Hello, in this SFML video, we're going to be covering the shapes that SFML allows you to draw. So this is assuming that you've set up a project on Mac or Windows. Doesn't matter whether it's on Mac or Windows, there'll be no code that won't run on Mac or Windows. So the first shape we're going to be looking at is a circle shape. I think you can guess what it does. It creates a circle. To create a circle within SFML, you do SF, which is the SFML namespace. So we're just going to access circle shape. We're going to call it circle, and you can just initialize it with a radius. So it has a diameter of 130. You can also initialize it with another optional parameter, a secondary parameter, which specifies how many sides it has. Because you might be thinking, a circle doesn't really have any sides. It's just, one smooth circle. But in computer graphics and games, that's very computationally intensive, I should say, not intensive. Plus also, you can't really just get smooth circles in games. You've probably seen circles or something with a circle on it, like a barrel, for example. Half-Life 2 is a good example. I love that game. And you can actually physically see the edges. It might only have like 10 or 12. In the old games, they see only have like 6 or 8 different edges. So they would actually look like a octagon or a decahedron or something like that. Decagon, I think that's the shape I'm looking for. But you can specify how many sides you want, and we'll be looking at that in a moment. This is just a simple circle. To draw it, just go to here where we've got draw objects here. Just do window.draw, specify what you want to draw. For us, it's the circle that we created. Got to spell it correctly because it's RCL. And now if we run this, we'll have a circle in our window like so. So that's pretty simple, and that's pretty darn cool. What you can do, like I was saying, is specify how many points you want. So if I put 360, for example, that has 360 sides, it's going to be very circular like, and that's fantastic. But again, that's computationally intensive. The more shapes you have, the more sides, the more processing power required. If you have 36 and you run it, you'll notice that there's virtually no difference, but it's still, it looks good, but it's only got 36 sides. And if, let's say, I put 18, you'll now be able to notice each individual side. So what you actually need to do is get a balance, as you can see. Let me just zoom in. You can see each side. So you need to get a balance between having a lot of sides versus the performance. By default, SFML uses 30, and that works very well. But another great thing about having a circle that allows you to specify sides is you can create other shapes. So if I were to put 3, what sort of shape do you think this is going to create? It's going to create a triangle. If I were to put 4, it'll be a quad. If I were to put, let's say, 5, it'll be a pentagon. Like so. 6, 7, 8, 9, 10. I think you get the picture. What you can do is, I'm going to actually just get rid of this. 30 is fine. You can set the radius and the amount of points afterwards as well. To do that, you just do circle.set radius. And for this, if you were to, let's say, put 55 now, I'm going to put a small value so you can easily notice the difference. And circle.set point count. So if we were to put 15, let's say we put 12, run that, and we didn't spell circle correctly, so now run it, we'll have a small circle with 12 different points. I'm just going to comment this out, but that's just a way of setting the radius afterwards as well. Maybe you're updating your shape. You might be looking at it and thinking, oh, it's only white. What's so special about that? Can we change the color? Yes, you can. You just do circle.set fill color, and you do SF : color. and you just open brackets, and in here it takes 3 parameters, a red, green and blue, which range between 0 and 255. The higher the number, the more intense that particular color is in the final color calculation. So I'm going to put 255, 0 and 0. So what we'll have is a red circle with a radius of 65. Pretty cool stuff. You can also set the outline color. To do that, you just do circle.set outline color and SF color, like so. And for this, I'm going to specify 0, 255 and 0. So what we'll get is a green outline. If we run it, let's see what result we get. You might be looking at it and thinking, you can't see a outline, no green outline. The reason for that is you need to set a thickness. To do that, you do circle.set outline thickness, and for the thickness I'm going to say 15, so this is going to be pretty darn thick. So let's run this now, and we have a thick outline. But one thing to note is that it extrudes out instead of going in. The outline does. So what your circle effectively has in terms of a radius is the initial radius, which is 65, plus the thickness. So the radius is actually effectively 80. If you want it to go inwards and you want to restrict the radius to this value, you specify a minus number. So if we do minus 15, still has an outline thickness of 15, but it goes in now. So pretty cool stuff. Another thing you can do is actually set a texture. I've already got an image which we'll load into our SFML texture in a moment, and I've put it where my main.cpp is. Created a folder called res, which stands for resources, img, which stands for images. Then I've got an image here called brick.jpg, sports png, and a variety of other formats as well. So to load a texture, we just need to do sf texture. I'm going to call it texture. And now we want to run a method called texture.load from file. But if we put it within a if statement, we can do if not texture.load from file, and we specify the path. So this path is relative to this particular file. So it's main.cpp, so we put rev/img/brick.jpg, and if this isn't successful, it'll enter this if statement, which means it has failed to load. So if I do std cout load failed and std end line, and I'm just going to do a system pause, which gives us some time to be able to see the console, because if it fails, we're just going to say return exit underscore failure. We're going to exit out of our application. So now if we run this, see what we get. You run it, and what happened? Let's have a look. So if we try, and let's just get rid of this, let's run it. So we get this right here. We need to open up the console window, which I can open up like so. It's saying load failed. You might be thinking, why has, well, the load failed even though we actually have that image here? You probably won't have this issue on Visual Studio, but on Xcode, so this is really just for the Mac users out there, the resources need to be where this executable is. So if we go to our code file, copy this folder, right click on products, go to show in Finder, paste it here like so. Any new resources, just add it here. Sometimes Xcode doesn't copy it over. So if I run it now, it has successfully loaded the image. You might be thinking, okay, but it hasn't applied it. To apply it, we need to actually set the texture to the shape. To do that, you just do circle.set texture, and you specify a texture like so. We're going to get an error now because we need to actually specify a reference to it. We're passing it by reference, so we put ampersand like so. And if we run this, we'll have a circle with a brick texture. Looks pretty cool. We've got our outline color and our fill color. So we're going to just comment that out because it's sort of just getting in the way of our texture that we've just applied. So if we rerun this, we get our texture. Looks cool. You might be thinking those bricks are pretty small, because essentially what it's done is applied the entire image, or the majority of the image, because it's a circle, you can't apply all of it. But what can you do to only, let's say, apply a portion of it? What you can do is set a texture rect. So if you do circle dot set texture rect, and you do sf : int rect, and this takes 4 parameters, and the first parameter is where you want your rect to start. So 0, 0 would be in the top left of the image, and if I put comma 10 and 10, for example, what it does, it starts in the top left, goes 10 across, 10 down, and it's that portion of the image that gets used. So if we run this now, we'll see what result we get. So you might be thinking it's looking really blurry, what's happened? Nothing's gone wrong, it's just this image is really high resolution. So to get any decent portion of the image, we need to go pretty far across and pretty far down. So I'm going to specify 500 as the width and the height. And as you can see, we have more of the image now. It's easily visible and it's a lot larger. You could, for example, specify a different X or Y value, and what this will do is distort the image that gets loaded. You might want that, but I would recommend just trying to keep it in squares, so that way you don't get any distortion. So that's it for really the basic properties of shapes. But now let's cover the other type of shapes that you can use in SFML. You can use a rectangle shape to do that. SF : rectangle shape. I'm going to call it rectangle, and you just put SF vector to F, and for this you merely specify the width and the height. So I'm going to put 100 by 60. So now let's draw this. So instead of doing window.draw circle, we do window.draw rectangle. If you wanted to draw multiple shapes or multiple different items, you just do multiple window.draw calls. So if we run this now, we'll have a rectangle with a width of 100 and a height of 160, as you can see right here. So let me just close this down, and you can specify the size later on as well. So you could do rectangle dot set size to SF : vector 2F, and you could specify, let's say, 500 by 450. So we're going to have a larger rectangle now, which is pretty darn cool. It's almost a square, and all of these properties that we've applied to the circle, the texture, the outline color, and the fill color, can all be applied to your rectangle. If you just put rectangle dot set fill color, you got set outline color and thickness, and set texture rect and texture. As we've already showed you how to do each one of these individual functions, I'm not going to show you again, and I recommend just using these and putting them on the rectangle to see what they look like. The next shape we're going to cover is a convex shape, which allows you to specify a number of points and specify the position of each one of those points, and SFML will just join them up and draw it. You might be thinking, what's a point? Let me go into here. We got this quad. Each corner or each vertex is a point, so we're going to be able to specify a custom shape, which is really cool. To do that, just do SF : convex shape. I'm going to call it convex, and you just specify a parameter of how many points you want. This is optional, you could just do this, but if you omit it, you want to specify the amount of points afterwards. But you can also update the amount of points as well by doing convex dot set point count to, let's say, 67. That's a lot of points. I'm going to comment it out because we only want to set 5 points. And to set each individual point, you do convex dot set point, The index refers to the point that you're specifying the position for. It ranges between 0 and n minus 1, which is 0 and 4 in this example, because n is 5. So we got 0. For this, we just put sf : vector 2f, and here you just specify the position. I'm going to put 0, 0, and 0, 0 starts in the top left. Positive x value goes that way, and a positive y value goes down. So I'm going to copy and paste this so we have 4 more instances of it, and just update this to 1, 2, 3, and 4. And now let's finally just set the points. You can put whatever you want. You're probably going to experiment with it to get the right shape for your game. These are some points that I've already worked out earlier on that look pretty darn cool. 45, 120, and 70. So we can't run this now because we need to specify the convex shape here for drawing. So convex, run it. And there we go, we got our convex shape. 0, 0 is here, the next point is here, the next one's here, next one's here, the final one's here, and it's automatically filled all of that in. You can apply all of these methods, the texture and the color methods, to the convex shape as well as you would for the circle and rectangle shape. One thing to bear in mind is the order in which you set the points is very important. You either want clockwise or anti-clockwise, because otherwise you'll start going over each other and the shape will just look all funky. So if we were to specify this as 4 and 3, so it'd be 0, 1, 2, then 3, then 4, you'll see you won't get the sort of shape that we just did, and it won't look very good. So that's what happens, and it looks like there's a lot more points. It looks like there's 1, 2, 3, 4, 5, 6, 7, even though there are only 5 points. So let's just sort this back out. And the final type of shape that we're going to cover is a line. This is very, very basic. So to create a line, you do sf : vertex, and I'm going to call it line, and it's an array, and we're going to assign some values to it. So semicolon. This is an array of size 2, and it'll automatically get the size based on the amount of values we put in here. And it takes a SF vertex, which takes a FF : vector 2F, and for the vector 2F is just the position of each end of the line. So I'm going to put 45 and 100, put a comma, and on here I'm going to put 200 and 400 like so. So now to draw this line, we just do window.draw line, for example, but we can't just draw it like that because it's not a regular type of shape. It's a bit more basic, so we need to specify number of points, which is 2, and then specify FF : line, so the way it's going to be drawn. And now if we run it, we'll get a really awesome straight line. So that's pretty cool. So that's a way of drawing straight lines. And you can also set the color by doing line square bracket 0. So this specifies the color or something for the first index, which is this one right here. And you just do dot color. There's no methods. You just do equal SF color. You can either specify a color as you have before with red, green, and blue, or you can do : red, for example. So red, and you can do this for every other instance that you use color for. And let's specify a color for the last point in the line, or on the line I should say. I'm going to specify the color blue. If we run this now, what we'll get is red on one side, blue on the other, and it interpolates between the two colors, which looks pretty darn cool. So we got this line with a color value. You can also update the position. So if we do line 0.position equals SF vector 2F, the same sort of parameter that we passed in here for the position, and I'm going to put 400 by 400. If we run this now, the first point is now in a different location. It's actually on the same Y plane, or it's in the same position on the y-axis, and that is pretty darn cool. You can't specify any texture or any sort of fill color or outline color or outline thickness. You can only specify colors like these and position points for the individual ends of our line, like so. So that's it for the different shapes. We got circles, rectangles, convex, and lines. If you have any questions, feel free to post them on our educational platform, sonarlearning.co.uk. There'll be a link in the description to that. Alongside that, there'll be a link to the GitHub page, which will have all the source code from every video in this series. If you like the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. And as usual, thank you for watching, and I hope you have a great day.